Hello, my name is Ala Kustnova, and I am an instructor at the CODDY School of Programming. This is the 15th lesson in the Minecraft Introduction to Artificial Intelligence course. The topic of today's lesson is conditional operators. Our goal is to introduce the concept of a conditional operator, learn how to use them in programs, and also learn how to create conditional constructs. And we will write several programs that use conditional operators to check some input values or values that are stored in variables and so on. In other words, by the end of our lesson, students will have learned to use conditional operators in programs and completed several programs to check input values. So the procedure for this lesson is the same as all the previous ones. We start with the homework, actively discuss it, and answer students' questions if there were any mistakes or difficulties. And only after that do we move on. Since we already touched on the topic of conditional operators in the previous lesson, today it will be much easier and clearer to use them. So let's start with the term. A conditional operator is an operator that executes certain commands contained within it only if a specified condition is true. But to make it clear, again, there are plenty of real-life examples that will help the students visualize this information. So in fact, conditional operators are all around us. We often hear things like, if you finish this assignment, then for example, you'll go out with your friends. That's a conditional operator right there. You need to complete the assignment. Only then will the main event happen and you'll go out. Or for example, if it's raining in the morning, then I'll wear pants instead of a skirt. So in the morning, we wake up and check whether the condition of rain is met. If yes, then we put on pants. If not, then we wear a skirt. And this is how it will look in programming. We'll see it through such fairly simple examples. Today, we won't be creating anything super complicated so that the students can fully grasp the logical aspect of this topic, and then later they can make their programs more complex on their own. So this is what a conditional operator looks like in a program. It can be found in the logic tab and looks like if true then. Well, for example, let's do this. When the chat command 1 is given, in the logic tab we enter the word if. Inside, the word true is already stored, meaning if true, that is, if this operator is activated, then for example, the action stored inside this operator will be executed as soon as we run the program. 1. And now the agent has teleported to us. But if we change true to false, then the condition won't be met and the agent won't move. But there can be many different conditions inside this operator. For example, we can write that if the agent senses a block under its feet, then for example, it will move up by 1 block. So as soon as we run the program, it's not guaranteed that the agent will perform this action. It will only execute if the conditions of our operator are met. That's it, it sensed a block, so it moved. But if we run this program again, the action won't be performed. Because the condition wasn't met, the agent doesn't sense a block under its feet. So using simple examples show the students how conditional operators work. Next, we'll figure it out. Here, for example, is an example. If it's night, then a zombie might appear. In all other cases, naturally, the command won't work. And there won't be any response at all. So, to reinforce conditional operators at this level, where you've already discussed it, here it is. One condition, one action. If the condition is met, one action happens. I suggest you write a small game. From my personal experience, kids really like this format for using conditional operators. We create a competition game where students enter the game with the same amount of weapons and they enter with the same goal. And whoever achieves this goal first wins. For example, if someone dies or runs out of weapons while trying to achieve this goal, they are eliminated from the game. So the game is actually very simple, but if you feel that in your team or group this competitive element might be a problem, that the kids might not like it or get upset, then of course it's better to play this game without the competitive element. So the format is actually very simple. All students write all the code elements on their own computers. And since they are writing pretty much the same program, you can also show them what it should look like. Each student writes the code for the chat game command. Of course, the commands inside the chat may differ, but the logic should be the same. After the game command, players receive exactly the same amount of weapons, but when it comes to equipment, they can choose one option according to their own preference. For example, in my case, it's a chest plate, but someone else might say, I don't want a chest plate, I want boots. Or I want a helmet. So, one type of protection. The students choose for themselves. That's it, and accordingly, when the check command is given, everyone's game mode is set to survival and the game difficulty is set. So they are left with this equipment in the game. Next, it's essential for us to specify what the victory conditions in our game will be, as well as the conditions for losing. Here, pay attention. Again, everyone writes this for themselves. Since we're hunting a specific mob, but again, you can come up with a scenario where each student has their own mob. That's also a possible option. Or everyone can hunt the same mob. So every time one of the participants fights a zombie and wins, their goal gets one step closer. For example, it was 15, now it's 14. And most importantly, we see this information in the chat. For example, Dima only has 14 zombies left to defeat. If someone defeats them all, meaning their goal reaches 0 and they've beaten everyone, then they get some prizes, switch to creative mode, and we see in the chat that they've completed their goal. Even if students are working on different computers, this will be important for recording results so that no one feels left out. So all of this will be duplicated in the chat. Now we also have losing conditions. We use a second variable for this. Here we used zombies to track progress toward victory, but we also need to use one for arrows. We also track this with a value. Each player has 40 arrows. Every time an arrow is fired, the value decreases. And if a player runs out of arrows before reaching the goal, that player is eliminated from the game. And if, for example, they lose a battle with a zombie or someone else, they also leave the game. So here, caution, attentiveness, and a certain, I don't know, stealth, anything you can think of. So the program is actually very simple. Here it is, our starting point. Here are the victory conditions and the losing conditions. And of course, at the beginning, we need to assign the necessary values to the variables. Let's write this out briefly. All right, here is our adventure game. How to give weapons and so on. I think the kids already know all that. Here is the command to give an item to the target. I won't write it out in full, but this is how you give an item. There's also the command to say any phrase like get ready or take your weapons or anything else. Then the players receive it. That's it. You can add a short pause after they've all received it. So they can put everything on, get ready, take their bows in hand and so on. Because after they get ready, the necessary game modes are enabled and everything starts. That is, all the students will need to run the game command at the same time. Then we'll need two variables. One variable for the zombie and one variable for the arrows. But to make everything clear and simple, we set our target in the zombie variable. Here it is, 15. And in the arrows variable, we set the number of arrows that everyone has. That's 40. And you can also write in the chat that the goal of this game is to kill 15 zombies while saving as many arrows as possible. Or something like that. Next. Every time a zombie is defeated or destroyed, that is essentially when someone defeats it, we decrease our zombie target by 1. We're getting closer to victory. In the chat, you can display how many zombies are left so that if students are in a shared world, they can also see this reflected and know the count. Then, and most importantly, there's the condition. We write that if the number of zombies is if our zombie variable equals 0, meaning we've defeated them all, then a message can appear in the chat saying that a certain student has won. They received a certain number of rewards, switched to creative mode, and so on. The same goes for losing. Every time we shoot an arrow, we lose one of our arrows. -1. You can also display information about how many arrows are left or choose not to display it. If the kids are in the general world, the chat will get very cluttered, so you might want to avoid using this command. And of course, Our condition, only here the condition will be if the arrows equal 0, then display information that the player, for example, has lost, and you can also throw them into creative mode or do anything else. Any message, any event can happen, and you can discuss all of this with the kids. Here it is, the minigame. Just by using this simple conditional operator, we already have a bit more possibilities for use. Minecraft serves as a versatile and powerful platform for creating and designing your very own unique games, and so this particular program is clear as an example of that concept. Let's move on to the next topic. Next up is conditional constructs. So what are conditional constructs? These are several conditions that are checked one after another. So look, we have a single conditional operator. There it is, the truth. And for example, we want to assign a random number to the variable a. Again, the examples are very simple so that the students don't get distracted by the complexity of the program, but focus more on the logic of writing the program. Let's say the variable can get a number from 1 to 5. I can only check one number. For example, if the variable a gets the number 1, then some event will occur. Like this. A chicken will appear, but if the number 2, 3, 4, or 5 comes up, the computer doesn't react at all. That is, it's just empty. We can expand the conditional structure and check all the numbers, for example, or some specific number. In all other cases, it means the wrong number came up, but that's a bit later. Right now, we'll look at the else operator. Let's stick to the idea that we can add as many conditions as we need. In our case, 5. 1, 2, 3, 4, 5. And for now, we'll remove this else part at the end. That's it. So now our structure can check any of the 5 possible outcomes, any scenario that could happen with our variable. So that's it. Here are our actions. You can also specify some events there. That's the second thing. You don't have to suggest what events might happen. The students can figure that out themselves. I think they'll write that themselves. So you've listened. What happened? We expanded the conditional structure so much that now any event that occurs within our variable will produce some kind of result, some kind of event. For example, we ran command 1, the number 2 came up here, the computer checked, 2 is not equal to 1, so the chicken won't appear. It moves on and checks. Here, a connect event occurred. Everything worked, so this animal will appear, the wolf. And here it's also important to explain to the kids that the computer won't check anything further after that. That is, as soon as the first match happens, it doesn't check anything else, no matter what comes next. That's why in some programs, which we'll look at a bit later, kids get confused. They set one condition there and then add 10 more conditions that are supposed to be met, but the computer won't even get to them. So it's clear that the more possible scenarios we think through, the more complex our conditional structure becomes, the smarter our computer, our program gets. That is, now it doesn't just react to a single event, it checks all the possible scenarios that might happen. Of course, if there are many more possible scenarios, our structure will also become broader. But this example is simple. Next, we'll look at what kinds of uses for conditional structures we can actually apply. So now we've launched the command and our program will respond to any event that gets assigned to the variable. And now our B has appeared, which means the number 3 was generated. And you can run the command again to make sure. Oh yes, wolf means command 2 was triggered. Number 2, that's it. So for now, you just discuss with the kids that you can build different conditions into the structure. And if the first ones don't match, the computer will have the opportunity to keep going and maybe find a match later on. All right, that's clear. We figured out how to expand a conditional structure. Now let's move on to the else operator, the one we set aside for now, but now we're going to use it. Let's leave it as is, for example. We'll even expand it a bit more so that if the variable gets Now our variable can take any value from 1 to 10, meaning there are a total of 10 possible outcomes. But we will use a conditional structure with only one condition and an else operator. That is, I want the computer to react positively in some way only if the number 5 comes up. For example, if the number 5 comes up, a chicken appears. In all other cases, no matter what comes up here, the computer will react as specified after the else operator. For example, the player might get some kind of wither effect. So we end up with a kind of casino. That is, out of 10 possible outcomes in total, only one possible outcome will be, in this scenario, made in a positive way. Everything else will be not so pleasant for our player. And from this, we understand that the else operator always triggers if the condition before it is not met, or if several conditions before it are not met. For example, we have an operator for 5, which checks for the number 5, but also one that checks for the number 9. That is, if the variable gets a number that is neither 5 nor 9, then the action after the else operator will be executed. Note that else has no conditions at all. It will trigger automatically if everything before it did not trigger. And this kind of else operator and this small conditional structure form the basis of such a fairly common program as checking an entered number. For example, in testing or in some other scenarios where there is a correct answer. Let's say my favorite program, which allows you to check the entered solution. Suppose we have an example. This example could be in a chat, or it could be written, for instance, in large letters in Minecraft. It doesn't matter how the students present their example. Then they will have the opportunity to do this right now. Each student will come up with their own example and write a program to check their example. So let's say I have an example, 10 plus 10. I ask one of the students to solve this example. That is, they enter my game and see, okay, my example is 10 plus 10. And when the chat answer command is given, they need to enter the correct solution for this example. But for them to see whether they solved it correctly or not, I need a conditional statement. So first, I link the variable to the chat, also called answer, and then I write that if any student who tries to solve my example enters the value 20 into the variable, then that will be the correct solution. The solution is correct. Any number, and this is where otherwise is really helpful, any number the player enters that is not 20 is an incorrect solution. The answer is wrong. We don't need to check a lot of possible scenarios because for this example, there's only one correct answer. That number is 20. Any other answer is incorrect. That's it. Here is our seemingly very simple program, but it already allows us to check, test, and so on. This way it works on any testing website. So that's all. Now that's everything regarding what we've already worked on. Here we see an example. You see it's printed there in big letters in the world. Here it is, right here. Perfect. I open the chat and type in the answer, space 20. That's it, the solution is correct. But if I write my answer equals something other than 20, for example, 21, that's it, the answer is incorrect. Ask the students to come up with their own examples, write a program to check that example, so they need to know the answer to their own example, and ask them to swap computers. But if it's, for example, an online class, then just take turns sharing your screen so that you can't see the program. That is, we run it directly from the chat or from the world and let the students try to solve each other's examples and the program will check their solution. Good, they handled that well. Now let's move on. So that's how you check the examples. Now, regarding double or triple conditions, that is, those particular cases where we can use more than one condition at the same time, but it's not a conditional structure per se. Here's what I mean. For example, with the chat command one, I want my agent to move up, specifically to move up by 10 blocks, but only if there is a block both to the left and to the right of it. In other words, the agent should only perform the upward movement if and only if it detects that there is a block present on both its left side and its right side. This means that the action is dependent on the simultaneous presence of blocks on both sides, not just one. So what do? We take the AND operator, that is the word and here we insert the condition that if the agent senses a block on the left, and if it senses a block on the right, only if there is a block both on the right and on the left will this action be performed. Let's test this out. Here is our agent. Here we have a block on the left and on the right. Let's try it with just the left side for now. So if there's only a block on the left, the command won't be executed. Or if there's only a block on the right, the command won't be executed. It also won't be executed if there are no blocks on either side. Only if both conditions in my operator are met will the agent perform the action. So that's how the word AND works between conditions. There can be more than one such condition. That is, we can specify that if there is a block on the left, right, and for example below, then only in that case will it work. There can be more than 1, 2, or 3 conditions. There can be an unlimited number. Now the agent needs to sense a block on the left, right, and below for this condition to be triggered. Alright, that's clear. Let's move on. And there's also the word OR. What does it tell us? It tells us that the agent can move up if it senses a block on the left or only on the right, or in those cases when there are blocks on both the left and right. So it already has 3 possible scenarios. So look, we only have a block on the left. We run the program, the condition is met. Now let's see, for example, the agent has a block only on the right. We run it, the condition is fulfilled. Of course, the condition will also be met if there are blocks on both the left and right. And only if there are no blocks on either side, the condition will not work. I think that's clear. Alright, these are some of the ways conditional operator constructs can be used in a program. Accordingly, at the end of the lesson, be sure to discuss what we accomplished today. Emphasize some important points, for example, how the else operator works, or even why we used a conditional operator in the program at all. And for homework, the students will need to create their own version of a mini-game in Minecraft, making sure to include both a win and a loss condition. For example, they might have a timer running, and if they reach a specific point before the timer runs out, they win. If not, they lose. Or it could also involve a battle, or for example, something like, or with resources, maybe within 10 minutes or seconds, or some set amount of time, players need to find the required number of resources. In other words, any options that the students can come up with. They can include them in their game, and that way the homework will be completed. That's all for now. Thank you for your attention, and see you at the next lesson. Bye bye.